Okay, good evening everybody. So today we are actually starting with the question answer sessions as Arun sir has already been teaching about probability and permutation and combination for the CAT classes. So we'll take this forward to non-CAT exams, mainly XAT, IFT, SNAP and MAT, which you will be taking by end of this year for next year session. So let me talk about some of these examinations. SAT stand for Xavier Aptitude Test. So it is for the institutes that come under Excelrai Jamshedpur. So they have Excelrai Jamshedpur and XIMB Bhubaneswar, which take admission through SAT examination. There are a lot of colleges other than that who actually take SAT scores for their entrance examination. Before I go further, let me check whether I am audible to everybody. If anybody has a problem, just raise. Okay, I believe I'm audible to everybody. So I'll go ahead. So I was talking about XAT examination. So a lot of colleges, mainly except Excelrai Jamshedpur and XIMB Bhubaneswar, they are not good colleges, but they are among top 30 at least. Some of the colleges who takes XAT scores as their basic criteria to entrance for entering into the colleges. And then we have an examination called IIFT. IIFT stands for Indian Institute of Foreign Trade. So it's a college which is located on two places. One is Kolkata and the main campus is in Delhi. So it is under Ministry of Commerce. So it's a good college for people who are looking for foreign trade management kind of courses or international management kind of courses. It's a good college. So uh, I was talking about IFT. So IFT basically is the first examination that you'll be actually countering with. So it's a competition. It's a college which will test not only your aptitude and English, but will also test your GS skills. So I just got somebody asking from uh, XIMB Bhubaneswar. Uh, XIMB is a good college. Who Ashish, XIMB is a good college. That is what I told. Except Excelrai and XIMB. So rest all are not that good college. They are among top 30, but they are not the very good colleges who take that scores. Avik, you're asking Calcutta University Department of Business Management. I believe it should be a good college, but it should be a good college, but I'm not very much aware about what is the situation of this. So I will not suggest you to go to that college because you are investing a lot of money and effort in order to get an MBA degree, and I don't want you to invest so much money there. Even if it is a means cheap college in terms of the number of money amount of money that you need to spend, but MFC of DU, so it's like it's a good college. Again, it comes under top 30. Goa Institute of Management is a good college. You can go ahead with that. It also comes under top 30 colleges of India. So I have few friends who are working with me from Goa Institute of Management. So okay, so that is Zach and IFT. So I'll be talking about SNAP. SNAP is for Symbiosis College. All the institutes that come under Symbiosis. So Symbiosis, SIBM Pune, and SCM HRD. These are the two good colleges in the Symbiosis category. Others are not that good. So others are not that good, but something like SIMS. For people with army background, it's easy to get in. They have a reservation there, so they can try there. Then we have NMAT. NMAT is for Nasim Munji Institute of Management Studies. So they have two campus. One, I think three campus. I don't remember. Hyderabad also it is a campus. So they have Nasim Munji Institute of Management Studies Mumbai, which is their prime colleges, and the second is NMIMS Bangalore. So coming on to this class, so let me introduce myself. My name is Rajeev Upadhyay. So I did my MBA from NITI Mumbai, so PGDIM course, 2011-13 batch. So currently I'm working in Bangalore. So I'll be instructor for today. So let me take some of the questions that they are coming. So NITI Mumbai is a good college. It has been consistently among top 10 colleges. So anybody who is trying to get into through GATE examination or CAT examination, it's a good college to be in. But only criteria is you need to be an engineer in order to get into this college. So I believe everybody is, or my voice is audible to everybody. Is it okay, Sakar? Devansh, we will solve questions, don't worry. So it was just an introduction. It was my first class, so I just wanted you guys to be familiarized with the examinations. So let us go ahead with the question today. So we have some of the questions which are from last year few papers, or some of the questions which I made myself. So it's like we'll be talking about, I think Arun Sharma sir has already taught you about probability and permutation combination. So permutation, combination, probability, let me tell you about the questions in that IFT and other examination other than CAT. So you won't find a lot of tough questions if you have prepared very well for your CAT examination. So you'll be able to crack all the questions from probability and permutation and combination for all the other examinations. So I've tried to consolidate some of the questions, and I'll let you solve these questions, and then we can actually see how it is going ahead with this. Then we'll go ahead with a different approach if it is not working out. So what my approach is, I'll give you first 3 questions and I'll give you 5 minutes to solve those questions, and then we'll see each question one by one and understand the concepts of the questions. So if you guys are ready, let's go ahead with the questions. Okay, first 3 questions. I think you all have the question sheet shared with you. So you can go ahead and solve first 3 questions. And right now it is 7:10. Okay, no problem. It's question number 2 and question number 3. That is a typo mistake. So take question number 4. So question number 1 to question number 4 and solve it in next 5 minutes. So 7:15 we'll see what is going on. Okay. For those who don't have the question sheet with them, they can directly see the question on my screen, or I can actually paste these questions. I'll try to paste these questions. Yeah, I believe everybody has got those questions, all the questions. So Now you can, so Sheetal, Siddhartha, so you can solve these questions. Those who have, they can start solving these questions. The question sheet I have sent to Mindworks, so they should have sent it, but I believe some of them, I think some of them have not got these question sheet. So no issues. You can solve the questions I have pasted in chat window. So you can go ahead with that. I've already shared it. So from next time, maybe you'll be getting these question sheet much in advance. Okay guys, 7:11 now it is, 7:16 we'll meet. Let's see who gets. And I'll suggest that you guys start, when you are solving any questions, just reply it on your chat, each and every question when you are solving. Give me the answer. That will give me a feedback that whether you are solving it or not. And I'll suggest that you solve right now these questions. Don't think that you can solve it at point in time somewhere when you are okay, or when you are a little more free, because this is will be a right kind of testing environment kind of thing, uh, which you will be actually encountering when you are getting the paper. Okay guys, so time is up, so I'll solve these questions with you. Question number 1. So let's understand what is the question. Question is, what is the probability of getting at least 1/6 in a single throw of 3 unbiased dice? So you know every dice has a 6 sides. So each of the dice will be numbered from 1 to 6. When a single unbiased dice is thrown, then you will have 6 possible outcomes. It will be 1, 2, 3, 4, 5, 6. If 2 are simultaneously thrown, so it will be 6 into 6, 36 outcomes. So we need to find out if 3 dice are thrown, then it will be 6 into 6 into 6, that will be 216 outcomes. Everybody is clear with that. So what we need to find out is the number of cases in which at least one of the faces shows 6. At least one means what? At least one dice, 2 dice, or all 3 dice. All 3 dice is 3. Now see, will make cases. So all 3 dice show 6. So how many? It can be possible only in one way. So the number of cases in which 2 of the dice shows 6 and one of them is a different number, so it will be an event called kind of 6, 6 and 5. So how many will be there? It will be or 6, 6, 4. Similarly, it will be, if you count, it will be 5 possible options. And now these 5 possible options can be in 3 ways. It can be here, so it can be 665 can be 565 or 566. So it will be 5 into 3. It will be 15. Now the third thing is when one of the dice shows 6 and other shows some different number, 6, 5, 5. So how many can be there? 25 kind of thing. So and it can be done in 3 ways. So 25 into 3, 75. So total will be 75 plus 176 plus 15 will be 91, and total outcomes are 216. So 91 upon 216. So this will be the answer, option number 5. We'll go ahead and mark option number 5. Now it's a big way, so you have to count. So there is a smaller way to do this question. The alternative approach what you can use is, hope everybody has understood this. Okay. See, how you are getting is 5. If you are fixing one number, 6, so to choose this and this number you have 5 ways and 5 ways, so 5 into 5, 25 ways you have to choose these 2 positions. Okay, now it can be arranged three ways. So it can be 565, 556 and 565, 556 and 655. So 3 ways can be arranged. So 25 into 3, 75. Hope everybody is clear now. Or still you need explanation on this. See, how you are getting 5 here is you are actually putting this and this constant, and this can change how many ways? 5 ways. Now you're putting this constant and you are changing this and this. This can be changed in 5 ways, this can be changed in 5 ways, so 5 into 5, 25. Now it can be done 3 ways, so 5 into 5, 25, into 3, 75. Here 5, and it can be done 3 ways, so 5 into 3, 15. Okay, so hope everybody is clear. So this is a big approach that can be done. So I'll show you an alternative approach to solve this question. See, the alternative approach is 1 minus. So what you can do is find the number of cases in which none of the digit is 6. If none of the digit is 6, that means 1, 2, 3. These 3 you can choose in 5 ways. You can choose in 5 ways. You can choose this in 5 ways. So none of them is 6. So 5 into 5 into 5. So that is 125. And total number of ways is 216. So how many are favorable cases? 91. And total is 216. So 91 upon 216. So we'll go ahead and mark this option. This is a alternative approach. See, Aparna, this is not about choosing a number 5. I'm choosing the number of ways in which you can choose that number. See, it can be 1, 2, 3, 4, 5 and 6. So other than 6, you can choose a number in 5 ways. That is 5 ways. It's not number 5. Hope you are clear with that. Okay, everybody? Okay. So this question is clear. Hope everybody is clear with this. So we'll move on to question number 2. Okay, if still anybody has a doubt, so you can chat me. You can send me a private chat for that. Okay, moving on to question number 2. What is the probability that a 2-digit number selected at a random will be a multiple of 3 and not a multiple of 5? Okay, how many 2-digit numbers are there? Everybody knows there are 92-digit number. What is the divisibility or multiple rule of 3? Every third number is divisible by 3. So how many numbers are divisible by 3? 30 numbers are divisible by 3. So now they are asking how many are multiple of 5. So 3 and 5. So it should be a multiple of 15. All those 30 numbers, I'll remove all the numbers who are multiple of 15. So 15, 30, 45, 60, 75 and 90. So 6 numbers out of this 30 are multiple of 15. So how many are left? 30 minus 6, 24 are left. So favorable cases are how much? 24 divided by 90. So 24 divided by 90 means or 4 by 15. So option number 2, go ahead and mark this option. I believe question number 2 everybody is clear. So I'm getting somebody is asking 93, 96, 99. Dude, see 90, when I say 90, that means 90 are the total number of 2-digit number. So 2-digit number starts from 10 and goes till 99. So how many numbers are there? 90, in which 93, 96, 99 everything is included. So we have a 90, let me repeat once again. So 92 digits numbers are there, out of which how many will be divisible by 3? Every third number is divisible by 3. So 30 numbers will be divisible by 3. So they are asking, they are a random multiple of, they are multiple of 3 and not a multiple of 5. So if it is not multiple of 5, that means it should be multiple of, means multiple of 15 needs to be removed, because it's a multiple of 3 and it's not a multiple of 5, so it should not be a multiple of 15, because LCM we need to take. So 15, 30, 45, 60, 75 and 90, out of these 30 needs to be removed. So we have removed that. So number of favorable cases is 24, total number of cases is 90. So what is our final outcome is 8 by 30 or 4 by 50. Okay. So moving on to the third question. I mean, third questions and second and third question are the same. So I've asked you to do question number 4. So question number 4 is a little tricky question. So question number 4, what they are asking. Question number 4 says 2 squares are chosen at a random on a chessboard. What is the probability that they have a side in common? So what is the number of ways in which you can choose out of a chessboard, in a number of ways in which you can so in a chessboard, number of ways in which you can choose first square is 64. Number of ways you can choose the second square will be what? You have already chosen one square, so number of ways left will be 63. So number of ways in which you can choose 2 squares will be 64 into 63. How much will be? 4032. Now, if first square happens to be one of the 4 corner ones, second can be chosen in how many ways? 2 ways. See, on a chessboard, if first square is chosen is this one, so number of ways in second square can be chosen will be 2. So if the first square happens to be any of the 24 squares on the side of a chessboard, the second square can be chosen in how many ways? 3 ways. See, suppose this is the square chosen. So how many ways? 1, 2 and 3 ways you can choose the second square. And if it happens to be one of the 36 remaining squares, suppose I am choosing one square here, how many ways you can choose other square? 1, 2, 3 and 4 ways. I believe everybody is clear with this. If you are not clear, I'll explain it once again. See, number of ways you can choose one square will be how many? In a chess, how many squares are there? 64. 8 this side, 8 on the vertical, 8 on the horizontal. So total is 64 squares. If you want to choose one square, you have 64 options. If you have already chosen one square, so to choose the second square, how many options you have? 63 options, because one is already chosen. So total number of ways in which you can choose 2 squares will be 64 into 63, 4032. Everybody is clear with that. Okay. Now what we are saying is, now you want to choose, if you choose one square on this or this corner, if you chose one square on the corners, on the four corners, so the number of ways in which you can choose the second square will be either this side or this side, means two ways. This side or this side, two ways. This side or this side, two ways. This side or this side, two ways. Now, on these sides, in the first column itself, if you see, so they are these squares, 6 are left here, 1 2 kind of thing, 6 and 6. So these 24 squares, if you choose, then how many ways you can choose the other square? 1 2 and 3 ways. And what is left? 24 plus 4, 28. So the left are 36 squares. If you choose that one of that 36 squares, so how many ways you can choose the other square is 1 2 3 and 4 ways. So the total number of combination will be what? 4 into 2 plus 24 into 3 plus 36 into 4. It will come out to be 224. And total total cases are 4032. So it will come out to be 1 by 18. So we'll go ahead and mark option number 1. Is everybody clear with this? Okay, I believe people are not clear with this. Okay, let me explain it once again. What is the question? Question is, two squares are chosen at random on a chessboard. What is the probability that they have a side in common? How the chessboard looks like? Chessboard looks like this. You have 8 squares here, 8 squares here. Okay, so the number of ways in which you can choose two squares will be 64 into 63. Everybody is clear with that. If anybody has a problem with this, please raise right now. Okay, I think everybody is clear with this. Okay, so 1 2 3 4. So you are saying to choose two squares you have 4032 ways. Everybody is clear with that. Now the second part. Now it is saying that what is the probability that they have a side in common? How can you have a side in common? If you choose, see, there will be three cases in that, because three types of squares will have side common. One will be the corner squares, 1 2 3 and 4, in which if you want to choose the second square, you have chosen this square and want to choose the second square, then if you want to choose the second square, then in that case you have only two ways, because two sides are already locked. You don't have any square here. So if you have chosen this corner squares, so you can choose the second square in only these two ways. So you have first component 4 into 2. Now if you have chosen the first square on these sides which are between these two corner squares, so 6 are there here, 6 are here, 6 are here, 6 are here. So 6 into 4, 24 ways. 24 squares. If any of these 24 squares you have chosen, so you have to choose the second square. How many ways? If you have chosen, see, this square you have chosen, something which is in between. So the two square, this has only one side on its horizontal. Similarly here it is on vertical. So you have left with 3 open faces. So the other square you can choose in 3 ways. So out of, if you have chosen this square, so 3 ways you can choose this square. So 24 into 3 ways will be the second type of square. If you have chosen something, see, in between any squares, so what is left? What is the number of squares that has been left? 24 we have chosen, and 4 this corner. So 28 we have already chosen. So out of 64, 28 you have chosen. So remaining is 36 squares. So these 36 squares, if you are choosing, see, suppose you are choosing one in between here. So how many ways you can choose the other square which has an adjacent side? So here 1, 2, 3, 4 ways are there. So for those 36 squares, you have 4 ways to choose the square. So we have 36 into 4 as our third component. So total number of ways in which you can choose a square which has an adjacent side will be 4 into 2 plus 24 into 3 plus 36 into 4, that will be 224. So and total cases are 4032. So 1 by 18 will be the probability. Everybody is clear or still needs explanation for this? Are you sure you are not getting the point? I'm not counting it double. Okay, let me make a figure out of it. Let us concentrate on only this question in this class. That will be much better if you have. See, this is a chess table. We have 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. One, two, three, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7, 8. Okay, this is the chess table. Okay, so everybody understood that to choose a square, two squares, we have 64 into 63, that is 4032 ways. Okay, now we have to choose a square that they have a side in common. Okay. Okay. First is we are choosing, suppose one case we are choosing any of these corner squares. If you are choosing any of the corner squares, so it will have one common adjacent, one square which has a common side with this square, and one square common side with this. So two ways you can choose the other square. So you can choose which squares? These two, these two, these two, these two. So 4 into 2 ways you can choose 8 ways. Okay, everybody is clear with this? Let me choose the second. So second is if you are choosing any of these squares. So this is what? 6 squares. Similarly here 6, 6 and 6. So total number is 24. So 24 squares, out of which if you have chosen any of these 24 squares, so how many ways you can choose the other square? If you have chosen, suppose this square you have chosen, so you can choose the second square as one, this or this, which has an adjacent side. How many ways? 24 into 3, that is 72. Now we are choosing any of these squares. See, how many squares are left? 36 squares are left. If you are choosing any of these squares, suppose you are choosing this square, So if you have chosen this square, so how many ways you can choose the other square? You can choose this square, this square, this square, or this square. 4 ways you can choose the other square. So 36 into 4 ways you can choose the other square. So it will be 144. Now you can add and do it. Hope everybody is clear now. Anybody still has a doubt? Ayushi, you have a doubt still? Yeah, Ayushi, tell me, what is the doubt here? Okay, hope everybody is clear now. Okay, Apurv. No, Ayushi, it's not double counting. You are not getting the point. So you are not getting the point. It's not double counting. It is, if you have chosen second, it does not mean that if you are, the same square can't be chosen twice. It depends that which square you have chosen first and then which one you will be choosing next, which has an adjacent square to that. It's not like one which has already been chosen, it can't be chosen again. It is the number of ways you can choose a square. Okay, if anybody still has a problem, he can send me an offline message, I can resolve that. Moving ahead. Kaushik, you are completely wrong. How can it be 24 cross 5? A square has only 4 sides. So if you have chosen one square, so other square can be chosen only maximum 4 ways. It can't be chosen more than 4 ways. So that concept is entirely wrong. So okay guys, moving ahead. We have to finish it in another 45 minutes. So we'll move ahead with this. I have a solution sheet as well, which I'll share in the end. So I've prepared that as well. So I'll share that with you. You can understand much more then. For all those people who have entered late or have not got the solution for questions 1, 2, 3, 4, everything. So I'll share the solution sheet as well with you all. So you can actually go through that. So I can't repeat everything once again. Okay. Okay guys, moving ahead. Question number 5, 6 and 7. Again, I'll give you 5 minutes to solve these questions. We have, say, 7:55 will see solutions for these questions. So let me tell you once again the type of questions that will be coming in XAT or SNAP or and MAT for probability and permutation combination. First of all, it won't be too much questions. It will be not more than 2 or 3 questions from these topics, and it will be pretty simple. So the questions like 5, 6, 7, these questions, 5, 6, or first, these will be the type of questions you will be getting in other examination, except that. That you can expect a lot of tougher questions. Questions like question number 4. These are the type of question you will expect in CAT or ZAT. But typically what I have seen in past few years, very few questions are asked from uh, these topics. Or either if they are asked, these questions actually are combined with number system or combined with time and distance, something like this. So it won't be asked independently. For everybody's information, I have already shared the question sheet. I'll be sharing the answer sheet also, which I have prepared along with that. So don't worry if you have missed anything. So question and solution sheet, the detailed solution sheet I have prepared for that. So that I'll be sending after this class. So this is the process that I'll be using for rest of my classes. So I'll be sending a question sheet before the uh, class starts, and then after the class I'll send the solution sheet. See, all these questions and answer sheet, whatever I prepare, I send it to Mindworks team. So you need to coordinate with them if you are not getting these questions sheet or on solution sheet. Okay guys, time is up. So we'll see question number 5, 6 and 7. Then we'll move ahead. So question number 5, when two dice are thrown simultaneously, what is the probability that the sum of these two numbers turn up less than 11? Okay. So it's a very simple question. How can it be simple? See, what is the maximum if two dice are thrown? So maximum can be, the sum can be what? 12. Okay. The sum of the two numbers turn up is less than 11. So maximum can be 12. If it is 6 5, it will be 11, or 5 6, it will be 11. So 3 cases are removed. So out of 36 cases, 3 cases only won't satisfy if the sum is less than 11. So 36 minus 3 upon 36. So that will be 11 by 12. So we'll go ahead and mark option number 2. Everybody is clear with this? The question is the sum of the two numbers turn up is less than 11, not greater than 11. So it can be less than 11, so it shouldn't be greater than 11. Got it? So greater than 11, how many cases can be there? If the number maximum, what can be the sum? It can be 12. So 6 6. It can be done only in one ways. After 12, what can be the number? 11. 11 can be done how many ways? Two ways. If it is 6 and 5, or first is 5 and 6. So two ways. If it is not 11 and 12, so it will be obviously less than 11. So these three cases, if we remove from the total number of cases, which is 36, so 36 minus 3 upon the total number of cases, that is 36. So it will be 33 upon 36. If you simplify these fraction, it will come out to be 11 by 12. Got it, everybody? Okay. Moving ahead to question number 6. Question number 6, 4 dice are thrown. What is the probability that the same number appear on each of them? Okay. So 4 dice are thrown. 1, 2, 3 and 4. Okay. So how many are the total number of ways? 6, 6, 6 into 6. So what is the total? 1, 2, 9, 6. Now the same number appears on each of them. So how can that be possible? If same number is appearing, so it can be done how many ways? It can be done in one, or 2, 2, 2, 2, or 3, 3, 3, 3. So 6 ways can only be done. So 6 upon 1, 2, 9, 6, which can be 1 upon 260. So we'll go ahead and mark option number 3. Everybody is clear with this? Karthik, why 6 ways? First of all, I'd like to say that most of the people have got 5, 6 and 7 questions correct. So Sony, Vivek, everybody. So why 6 ways is because there are only 6 numbers which can appear, and the same number has to appear on all 4 dice. So same number, which number can appear? Either 1 appears on all 4 dice. So 1, 1, 1, 1, that will be one case. Either 2 appears on all 4 dice, so 2, 2, 2, 2. 3 appears on all 4 dice, 3, 3, 3, 3, 3. 4 appears, 4, 4, 4, 4. 5 appears, 5, 5, 5, 5. Or 6 appears, 6, 6, 6, 6. So only 6 ways it can be done. So 6 upon 1296, 1 upon 216. So that's the easy thing. Okay, got it everybody? Moving ahead. If anybody still has a problem, just raise. I'll give you next 10 seconds to do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay guys, moving ahead. So question number 7. An experiment succeeds twice as often as it fails. What is the probability that in the next 5 trials there will be 4 successes? So it's a binary question which we... So what is it shows is an experiment succeeds twice and it is false. So probability of success, what it will be? Probability of success will be what? 2 by 3. So it is saying it succeeds twice, it is false. And private failure, how it will be? Probability of failure, it will be 1 by 3. Okay. Now what it is? Now it is saying in the next 5 trials, the experiment needs to succeed 4 out of 5 trials. So 4 out of 5 trials in which it will be succeed, how many ways it can be? 5C4. Easy stuff. 5C4. That is 5 ways. Now, as 4 of them needs to be success with a probability of 2 by 3, one needs to be failure with a probability of 1 by 3. So 5 into 2 by 3 to the power what? 4 into 1 by 3 to the power 1. So what option we have? Option number 3. We'll go ahead and mark option number 3. Is everybody clear with this? Okay. I think some people have a problem. The question is, an experiment succeeds twice often as it fails. So probability of success is 2 by 3, probability of failure is 1 by 3. Everybody is clear with that, no problem. Now it is saying that in the next 5 trials there will be 4 successes. Okay, let me explain it once again. What does it mean? See, next 5 trials, 1, 2, 3, 4 and 5, out of which 4 needs to be successes. Of which 4 need to be successes? These 4 can be success, these 4 can be success, these 3 and this will be a success. So how many ways you can choose these 4 success out of this 5 experiment? 5C, 4 ways. So that means 5 ways. And now what it is saying, it needs to succeed 4 times. So what is the probability of succeeding 4 times? 2 by 3 to the power 4. If it is succeeding 4 times, it needs to fail 1 time. So 1 by 3 into 1 way. So 5 ways you need to choose of these 4 successes, and probability of success is 2 by 3 to the power 4 and probability of 1 failure is 1 by 3 to the power 1. So it is 5 into 2 by 3 to the power 4 into 1 by 3. Is everybody clear now? Anybody has a problem still? Devansh, 2 by 3, if you see the question first line itself, it is saying it succeeds twice as it falls. So if 2 times it succeeds, 1 time it fails. So probability of success will be 2 by total number of cases 3. So that is why it's 2 by 3. And probability of failure will be 1 by 3. So it is saying it succeeds twice and fails once out of 3 cases. Hope everybody is clear with that. Okay. Ritvik, power of 4. Power of 4, why we have done is, out of this 4, see, if it is succeeding this, so 2 by 3. If it is succeeding this, 2 by 3. So 4 times it needs to succeed. So 2 by 3 into 2 by 3 into 2 by 3 into 2 by 3. That is how it becomes power of 4. See, hope you have studied about binary thing in probability, in which we write 5CR into PS, okay, PS to the power 5 minus R, and P upon is equal PP to the power R. So this I think you have studied in your probability. If you have not, just go and read the Arun Sharma book, you'll get it. Still you have, okay, 5 is multiplied. Sheetal is asking why 5 is multiplied. See, out of this 5 experiments, you need to choose 4. How can you choose? How many ways you can choose those 4 experiments? 5 ways you can choose. 5C4. That is why we have multiplied 5. Anybody still has a problem on this? No? Okay, guys. Okay, we have last 2 sets remaining today. Let's go ahead with that. Hope you guys enjoying this class. So question number, let's moving ahead. Question number 8, 9 and 10. So question number 10, options are, I can't paste the options in your chat window. So I've sent you the questions. For those who can see the questions, they can directly do it from the screen. And for question number 10, I can't paste the options. The options are actually images, so I can't paste those options. So you can just see the options and give me the answers. So question number 8, 9 and 10. It's on your screen. You have, say, 6 minutes to solve, 8:15, 7 minutes to solve these questions. I'm giving you too much time. CAT or ZAT or IFT won't give you that much time. So in 7 minutes, you have to solve these 3 questions. Okay guys, time is up. So let's see. We'll see question number 8. Question number 8 is an anti-craft gun can fire 4 shots at a time. If the probabilities of first, second, third and the last shot hitting an army tank is zero point 0.7, zero point 0.6, zero point 0.5 and zero point 0.4. What is the probability that 4 shots aimed at an enemy aircraft will bring the aircraft down? So it's very easy. See, any shot that will hit the enemy aircraft, it will bring it down. So we just have to find out that if none of them, all the 4 shots, none of them hit it. So we'll subtract it from 1, we'll get the answer. So none of them, if it is hit, how we'll find out? We'll find out in this way. See, hitting enemy tank hitting is 0.7, so not hitting is 0.3. For second, 0.6 is hitting, so for not hitting it will be 0.4. Hitting is 0.5 for third, so not hitting is 0.5. That is, I'm doing 1 minus this, 1 minus this, 1 minus this. 1.4, so not hitting is 0.4, 0.6. So if 4 of them simultaneously does not hit, then army aircraft will escape easily. So what it will be? This is star this into this into this. So it will be 0.036. If any of them fired shot and it hits the enemy aircraft, it is down. So 1 minus this will be the required probability. What it will be? 0.964. We'll go ahead and mark that option. Anybody has a problem with that? Anybody has a problem with question number 8? Okay, I believe nobody has a problem with question number 8. Okay, some people are asking why don't we multiply all the probabilities and find out. See, you're not getting the point again. What it is saying is 0.7 is the probability of first aircraft hitting the enemy aircraft. 0.6 is the probability of first aircraft hitting the aircraft. 0.5 is the probability of hitting third bomber to hit the third anti-aircraft gun to hit the enemy aircraft, and 0.4 is the probability of fourth anti-aircraft gun to hit the target. Now if you are multiplying all these 4, what you are actually calculating? We are calculating that all 4 of them shot the enemy aircraft at the same point in time. We are not calculating that all the 4, it will bring it down. It will bring it down, aircraft will be brought it down with any of them hits the enemy aircraft. So it will be calculated as 1 minus none of them hit the aircraft. None of them hit the aircraft means first did not hit, so 0.3 is the probability. Second did not hit, 0.4 is the probability. Third did not hit, 0.5 is the probability. And fourth did not hit, 0.6 is the probability. Now all 4 of them simultaneously did not hit. So it is 0.3 into 0.4 into 0.5 into 0.6, that is 0.036. Palas, you are not getting this. Is a probability question. You don't know. See what Palash is saying. Palash is saying if the first hits, then no question of further hit. Yeah, I know. But do you know whether first will hit or not? That is what the probability we are finding out. Okay. Okay, guys. I think everybody is okay with this. We'll move ahead to question number. Sampath, we can do that, but that will be a tedious process. You have to calculate 16 probabilities out. You have to calculate every time 4C1. So, but it's a tedious process. So instead of that, what we'll do is we'll calculate when none of them hit and we'll subtract from the overall probability, that is 1. That is the easier way to do this question. I'm correct? You're correct that we can do this either first hits or second hits or third hits or fourth hits. So number of permutations and combinations that you need to do is too much. Okay, guys, let's move ahead to question number 9. Question number 9 says, a number is selected at random from first 30 natural numbers. What is the chance that it's a multiple of 3 or 13? It's a very easy question. See, first 30 natural numbers, that means 1, 2 and so on till 30. So how many will be either a multiple of 3? How many it will be a multiple? 10 will be a multiple. 10, every third number is a multiple of 3. So 10 numbers are multiple of 3. And multiple of 13, how many it will be? 12 and 13 and 26. So it is 12. 12 by 30 will be the favorable cases. If you simplify it, it is 2 by 5. Okay guys, I think everybody is okay with this. So 30 numbers 1 to 30, they are natural numbers, out of which they are saying multiple of 3 or 13. 3 number of multiples will be 10, 13 it will be 2. So 10 plus 2, 12 are the favorable cases. About the number of sample space, that is 30. So 12 by 30, that is 2 by 5. We'll mark option number 2. Now if see this question, now see if question changes to 3 and say instead of 13 this is 15. Now in that case what will happen is you have to remove the, see 15 will be a multiple of 15 as well as 3. So you need to remove that, you need to remove that double counting thing. So that you need to keep in mind. And if you are taking 13, there are no double counting because 13 and 26 they are not divisible by 3. Hope everybody is clear with this. Anybody still has a problem? Okay, some people are asking if the total should be 10, how the total should be 10? It's saying 3 or 13. So it is not saying 3, only 3. Then it will be 10. If it is saying 3 or 13, we have to take both the cases. Okay guys, I think everybody is clear with this. Let's move ahead. I'll give you 5 seconds if you have any problem. Devansh is, in case of 3 or 15, the answer will be, yeah, the answer at that point in time we can calculate. Okay. Okay, Aparna, I got it. You're saying that if it is 15 instead of 13, but just be a little more exhaustive about it. I won't understand what you're talking about. Okay, guys, I think everybody is clear with this question. Moving ahead, we won't waste much time on these simple questions. Maninder, you can actually do it yourself. If you still have a problem, drop me an email for that. It's not a problem. 3 or 15, you need to calculate, you need to find the favorable number of cases. See, the best way to solve these questions is write the number down 1 to 30, find out the number which are multiple of 3, find out the number which are multiple of 15 and solve it. Now if the question changes to number 100, So the best way is always take a small sample space and try to solve that. Then you can extrapolate it to 100 or 200, because if it is following between 30 or 40 something, it will follow for 100 as well. So you just need to find the pattern. Some of these questions actually appear for all you people. These questions are at par with CAT as well as other examinations. So it's not like these questions can't come in CAT examinations. So these are at par with the CAT examinations as well. So some of them might be of higher level than CAT itself, but it is at par with the CAT examination. So you'll get questions like these. Okay guys, moving ahead to question number 10. A man can hit a target once in 4 shots. If he fires 4 shots in succession, what is the probability that he will hit the target? See, again, this question, what you can do is, it is saying that it can hit the target, okay, in 4 successions. Now you are saying that if he fires for hit once in, so again, same as question number 8, will consider that it does not hit the target in 4 succession. So what is the probability of failure? 3 by 4. So in 3 by 4 into 3 by 4 into 3 by 4 into 3 by 4, all 4. So what we'll get is 81 by 256, and we need to subtract it from 1. So it will be 1 minus 81 by 256. It will be 175 by 256. So that will be the required probability. It is saying that a man can hit a target once in 1 by 4 in 4 shots. That means hitting the target, its probability is 1 by 4. If he fires 4 shots in succession, what is the probability that he will hit his target? So if any of them hits the target, he hit the target. But I'm saying that none of them hit the target. None of them hit the target. What is the probability? 3 by 4 to the power 4. That is 81 by 256. You remove it from the total probability 1 minus 81 by 256. That will come out to be 175 by 256. Oh, okay, Aparna, you're saying that why not 1 by 4 to the power 4? 1 by 4 to the power 4, what it will be the probability? It will be the probability of him hitting each and every of the 4 shots. That is not what we are going to find out. Okay? Hope you're clear. 1 by 4 is its probability to hit one time at the target. So if all 4 of shots he is hitting the target, then it's 1 by 4 into 1 by 4 into 1 by 4 into 1 by 4. That is 1 by 256. That will be the probability of him hitting all the 4 of his shots to the target. Hope everybody is clear. No? Okay. See, the second sentence meaning is what is the probability that it will hit his target. It does not mean that it hit all 4 of his shots to target. Any of the shot, if it is hitting the target, that means he has hit the target. If they have to ask the question that he hits the target in all 4 shots, they will give this questions that he hits the target each and every time. That it means. What it means, what we have to find the probability here is he hits the target even once, twice, thrice or 4 times. So all 4 cases we have to include. So in order to find that cases, what we will do is we will subtract 1 minus the case in which he does not hit the target even once. That is what we are doing here. Is everything clear? Ravendra? Hope you are clear. Or let me explain it once again. I'll give 1 more minute to this. Guys, okay. Okay, I think everybody is clear now. So we'll move on to question number. Okay, guys. Moving on to next questions. We have two more questions. Now these two are very tricky questions. Question number 11 and 12. Okay. Okay, I've shared the question in your chat window, both these questions. So you have 5 minutes to solve these questions. 8:37 we'll discuss these. Okay, Vivek, what you're talking, let's see. So both the questions I have already shared in chat. Let me do it once again. I've shared with the entire audience so you can see from that. Okay, meanwhile people who are solving these questions, you can put on mute and solve these questions. Okay, let me answer people who have still have a problem. Okay. So Ritik, what you're saying is target once in 4 shots. No, this is not the question is. You need to understand the question. Question is he hits the target. He hits the target will comprise that once he hit the target, twice he hits the target, thrice he hits the target, or 4 times hits the target. It will only not comprise of the condition when none of them hit the targets. So what we are doing is we have taken probability. The total probability is 1. We'll subtract the condition in which none of them hits the target. So 1 minus 3 to by 4 to the power 4. That is how we got it. Hope you are clear. Okay. So 8:37 will solve these two questions. Okay guys, time is up. So we'll solve these two questions and wind up session for today. So the question is, it's a little tricky question. Three good students were sitting next to each other. What is the probability of them having same incorrect choice for 4 consecutive questions? See, if you see these questions, can you even find the answer for this? The answer is can't be determined. Why? Because probability of selecting a wrong answer, how can you calculate it? If you take 0.8, 1 minus 0.2 will be the answer, but there is a probability that everybody does not attempt all the questions. If he does not attempt the question, how can you find out the probability of it? So we need to, so we don't know that, so we cannot actually determine that. So the answer should be can't be determined. Okay, so everybody is clear with this. This is one of the question which I remember was asked in ZAT examination, one of the ZAT examination. Then question number 12, it shows 6 playing cards are lying on the table with face down. 2 of them are kings. 2 cards are drawn at random. Let us denote a probability for each one of them of card is drawn as king. B denotes the probability of not drawing a king. What is the ratio of A by B? So A, probability of A, what it will be, the probability of A? Probability of A, it will be C. Let A denotes the probability of at least one of the card drawn is king. So one card is drawn king is 2C1, okay, into 4C1, because if out of these 2 cards which are kings, one is drawn, so rest 4 cards, one will be drawn, so 2C1 into 4C1 of the total 6C2, so it will be 9 by 15. Similarly, probability of B, what it will be? 4C2. Now they are saying that not drawing a king, yeah, means rest 4 cards, everything is drawn upon 6C2. What it is? 6 by 15. Now they are asking what is A by B. So PA by PB will be 9 by 6, which will be 1.5. So answer will be option 5. There's a, I think I've missed out one thing. So this probability of A is at least one of them card drawn is a king. So if one is king, if both are kings, so I need to include that as well. Let me do that once again. Sorry. Okay. In probability A, we have at least one. So one is king plus both are king. So probability when one is king will be 2C1 into 4C1 upon 6C2 plus 2C2 upon 6C2. The value will be 9 by 15. And probability of B will be 4C2 upon 6C2, that is 6 by 15. So PA by PB, how much it will be? PA by PB, it will be 1.5. Option number 5. Okay. So people are, okay, Aparna, you're saying that you're not understanding what is PB. So PB is 4C2 upon 6C2. How it is coming? B denotes the probability of not drawing a king. So we are saying that out of 6 cards, 2 are kings. Okay, let me explain this question once again. 6 playing cards are there, out of which 2 are kings, 4 are not kings. So 2 cards are drawn at random. Let us, probability of A denotes that at least one of the card is king. So there can be 2 cases. One is king or both are kings. So if one is king, so other will be, so one card needs to be selected from 2 cards which are kings, and the next card should be selected about the rest 4 cards. So 2C1 into 4C1 upon 6C2 plus, if both are kings, so 2C2 means both are selected, both of the cards are selected, both kings are selected, 2C2 upon 6C2. So the total is 9 by 15. Now probability B, what it shows is of not drawing a king. If you are not drawing a king, that means you are selecting from first, the second 4 cards out which are not king. So 4C2 upon the total is 6C2. So 6 by 15. Now PA by PB is 9 by 6, that is 1.5. So it is greater than 1.25. That should be the answer. Still anybody has a problem? Probability does not depend upon the order of selection, Ravinder. Okay guys, I think the class needs to end now. Class needs to end now, so I'll send you the answers. So class needs to end now, so another class is waiting. So good night people. Great, thank you. We'll see you in next session. Good night people. Okay, bye bye.